drawing Lewis structures. In the last chapter, we studied about types of compounds, ionic compounds and covalent compounds. And we also discussed that covalent compounds are formed by the sharing of electrons between nonmetals. Now, one way to show the sharing of electrons is by drawing the Lewis structures, and these structures help us to understand the physical and chemical properties of the compounds. So first let's talk about Lewis symbols. What is a Lewis symbol? It's you write down the symbol of an element and you put the number of valence electrons in the form of dots around the symbol of an element. And the number of valence electrons is basically the group number. For example, if the element is in the first A group, then it means it has one valence electron. Second A group, two valence electrons. Third A, three valence electrons, and so on. So let's look at, for example, I'm going to cross out helium and I will tell you the reason in a minute. Let's discuss with lithium. Lithium is in the first A group, so it has one valence electron. So you put the symbol of lithium and then you put one dot. Now that dot can be anywhere in any around lithium, in any four corners, here, here, or here. But remember, we have to put only one dot. So let me lithium with one dot. Beryllium is in the second A group, so it has two valence electrons, so there will be two dots. Now do not pair them up unless we are done putting four dots in each corner. So, and you can pick this corner, any corner you can pick. Magnesium, second A group, two valence electrons, so 1, 2. So when we are writing aluminum, three valence electrons, so three dots, 1, 2, 3. But if the covalent compounds are formed by the sharing of electrons between nonmetals, then these are basically the metals. So that means they will not participate in the covalent bonding. So we will not use these much in the covalent bonding. In fact, we're not going to use them at all. So these are the main elements that we use in the in the covalent. Carbon is in the fourth A group, so it has four valence electrons. So you draw four dots around carbon, 1, 2, 3, 4. Nitrogen has five valence electrons, so 5 dots. And how will you draw those 5 dots? First you will put one dot in each corner, 1, 2, 3, 4, and then you start pairing up, but then you can start pairing up at any corner. Oxygen, 6th A group, 6 valence electrons. So here 1, 2, 3, 4, 5, 6. Fluorine, 7th A group, so 7 electrons, 1, 2, 3, 4, 5, 6, 7. Hydrogen has one valence electron, so you're going to draw one dot because hydrogen is in the first A group. Now, predicted number of bonds. Now, keep in mind, we discussed that in the last class that elements are stable if they have octet. Octet means 8 electrons in the outermost shell, except hydrogen. Hydrogen is happy with 2. So, if carbon already has 4 electrons, then it needs 4 more electrons to be stable. 4 plus 4 is 8. So, we're going to write down that you will see 4 bonds around carbon. What are bonds? That you will see on the next slide. Nitrogen has already 5 valence electrons. It needs 3 more to be stable, so it makes 3 bonds. Oxygen, 6 valence electrons. So predicted number of bonds are 2. 6 plus 2 is 8. 7. Fluorine has 7. 1 more, so to be 8, so 1. And hydrogen Hydrogen is the exception. Hydrogen is happy with 2. So if it already has 1 valence electron, that means it needs 1 more, and 1 plus 1 is 2. So you see 1 bond around hydrogen. So let's see what these bonds are. For example, we're going to practice to draw the Lewis structures for CH4, NH3 and H2O. CH4 methane, is that a covalent compound? Yes. Why? Because both carbon and hydrogen are nonmetals. So that means this compound is formed by the sharing of the electrons. So let's fill this table. Carbon, which group is in the 4th A group? It has 4 valence electrons, and Lewis symbol is you put 4 dots around carbon. Hydrogen, 1st A group, 1 valence electron, and the symbol is this. Now, so here let me change the color for hydrogen so that you can clearly see so hydrogen is in the 1st A group, 1 valence electron, and Lewis symbol is hydrogen with 1 dot. So now so let's go back and draw the full structure. So here we're going to put carbon in the middle, and these are carbon's 4 electrons, and there are 4 hydrogens in the formula, and each hydrogen with 1 valence electron. So here is hydrogen with 1 valence electron. So hydrogen is sharing this electron with the carbon, and carbon is sharing this electron with the hydrogen. Similarly, 2nd hydrogen, 3rd hydrogen with this electron, and 4th hydrogen with this electron. So now basically there are 2 electrons between carbon and hydrogen. So if you look here, carbon, and these are the 2 electrons. So these 2 electrons are drawn as a line, which we call it as a bond. So what is a bond? Bond is a shared pair of electrons, and one line is made up of 2 electrons, and one coming from the hydrogen, another one coming from the carbon. So these are known as bonds or bonding pairs. So how many bonds do you see around carbon? 1, 2, 3, 4. And that's what we said, that the predicted number of bonds around carbon are 4. The next is ammonia, NH3. So let's start with nitrogen. Nitrogen is in the 5th A group. It has 5 valence electrons, and its Lewis symbol is this. 4 electrons in each corner, and then you pair up. So I'm going to draw the same thing here, and again you can pair up anywhere you want, but you don't start pairing up unless you have put 1 electron in each corner. So the next one is the hydrogen. So hydrogen is in the 1st A group, 1 valence electron, and the Lewis symbol is this. So here, how many hydrogens are there? 3. So if you look here on this side, there are already 2 electrons. So there are 4 corners. We want to have 2 dots in each corner. That makes it 8. So there were already 2 here. So, and the sharing is equal. So here hydrogen is sharing 1 electron with nitrogen. Nitrogen is sharing his electron with hydrogen. So we'll put it like this. And then when we are writing it in terms of bond, since bond is formed by the sharing of electrons, I can draw the bond here, here, and here. But I cannot draw the bond for these electrons because these electrons are just on nitrogen. They are not combining 2 elements. So looking in the Lewis structure of ammonia, you can see there are 3 bonds around nitrogen. And that's what we said in the last one. Nitrogen predicted number of bonds are 3. Now, what about these electrons, the 2 electrons here? These electrons are known as lone pair. They are non-bonding electrons. Lone pairs are non-bonding electrons because they are not bonding to elements. But then again, how many total electrons you see around nitrogen? 2 here, these are 2, these are 2, and these are 2, so 8. So nitrogen is stable. Next is oxygen in water. So this is H2O. Oxygen is in the 6th A group, 6 valence electrons. Lewis symbol is 1, 2, 3, 4, 5, 6. So here I can draw it 1, 2, 3, 4, 5, and I can do pairing anywhere, 6. Then hydrogen, the same case. Hydrogen is in the 1st A group, 1 valence electron. Lewis symbol is this with 1 electron. Now these two, what are these two? They will not participate in the bond formation because they are already paired. So I can put 1 hydrogen here because hydrogen can share with 1 electron with oxygen and oxygen can with hydrogen. And so only the shared electrons can be represented in the form of a bond, and these will stay like this. So if you look how many bonds you see around oxygen, there are 2 bonds, and we said here 2 bonds. And what are these? These are lone pairs. So looking at the structure of Lewis structure of water, if you understand that oxygen is making 2 bonds or 2 bonding pairs, and it has 2 lone pair of electrons, then based on this information you can tell a lot about water.